Go. So my students have just finished discussing Teletubbies, so we're ready to progress now.
One of them died.
Apparently. So we're on to question 3 now. Hopefully this is the last video. And our first question is asking us to find the size of angle C. So there's C, in case you didn't see it. Yes. So we're going to use a few properties here of triangles. We may need to use similar triangles, do we? Or do we not? Okay. No, you tell me since you know it.
No, not for the first one.
Okay. What are we going to start with then? Angle A?
Yeah.
Okay. So let's say that angle A is 180 minus 125, which gives us 55 degrees. And our reason?
Angles on a straight line
Yep.
equal 180.
Excellent. So angles on line equal 180 degrees. Okay. That lets us work out angle D, which is 180 minus the angle we just worked out, 55, minus 44, which is the angle in the corner there.
81.
And that's 81, is it?
Yeah.
So 81 degrees. And our reason?
Angles in a triangle.
Yep. Angles in a triangle equal 180 degrees. Okay. So our last angle C that we're looking for is also going to be 81. And why is that?
Oh, because that's similar.
Yep.
Yeah.
So angles in similar triangles. Yeah, very cool. Okay, so there's our first question. Alright, question 2 is asking us to find the length marked X in this diagram. So X is this length along here. And what we can say is X divided by 10, we'll write this down here and I'll come back up again. X divided by 10 is equal to, what are the two sides? Well, the equivalent side on the big triangle is 18.
Would it be 18 plus 18 over
15.
Yep, 18 over 15. So I'll write that down here. 18 over 15. So one step of working here to solve this equation. One step of working to solve this equation. Times both sides by 10. Okay. And so X for this one equals... Do I need my calculator or has somebody got it already?
No.
So 18 divided by 15 times 10 is 12 centimetres. Okay. Alright, question 3, or part B. We're on to a different question now. Show that angle J is 120. Okay, so we'll start with angle X. Can anyone tell me what angle X is?
240.
Why?
because angles are
360 minus 120 plus 12.
Okay, and because angles around a point are 360. Okay, so our next one that we're looking for is J, and J is going to be 240 divided by 2, which is 120. And what's our reason for this one? So that's angles at centre. So the angles at the centre of a circle are always double the angles at the outside. Alright. Okay. The next question is asking us to find the sizes of angle H and angle K. So H is co-interior with 120, and so we can write, we can say that H is 180 minus 120. So H equals 180 minus 120, and so that's 60 degrees. And our reason for that is co-interior angles on parallel lines. Parallel lines. Okay. And J is K is the same reason, because J we just worked out as 120, and so K is going to be the same as well. So we can say that K is also 180 minus 120, which is 60, and the same reason, co-interior angles on parallel lines. Okay, so they're really flogging this question to death here, but explain how we know from parts 1 and 2 that the quadrilateral on the previous page must actually be a rhombus. You may wish to use the angle below. Okay, what are some properties of rhombuses? Yep.
What is a rhombus?
A rhombus has the property that all the sides are the same length, and all the opposite angles are also equal to one another. Okay? Yes, it says so. A square is a type of rhombus, but a rhombus is not necessarily a square.
So is that just like a special rhombus?
No, that's not a special rhombus. It's just it's a normal rhombus. Okay, so first of all, we need to say about the sides all being parallel to each other. So how can we say that they're parallel?
Well, it shows two sides parallel, but it doesn't show the others.
Yep, but we can tell that the other two must be parallel as well, because we worked out the angle of H and K. So first of all, let's just label all of the angles. We worked out that that's 120, that's 120, that's 60, and that's 60. Okay, so what does that mean about these ones here being parallel? Why does that say that those two sides are parallel?
Because the angles, the 60 and 60 are both the same. I mean, H and K.
Well, let's think about how we worked out 60. We worked out 60 because these two are co-interior and those two are co-interior. Okay, are they co-interior the other way? Yeah, so because they're co-interior the other way, they are also parallel. So we can say line HX and KJ are parallel, since co-interior with both sides. We'll say both adjacent angles. Okay, so that's one reason, and the language that you use is up to you so long as you explain that same point. So that's talking about parallelness. Now the next thing that we want to talk about is the sides all being the same length. So I can definitely tell that this side and this side are the same length. Why is that?
Because they go from the
Centre point
to the radius.
Yeah, so they're both the radius of the circle. So we can say that HX and XK are the same length. Okay, since they're a radius of circle. Or radii, since there's two of them, radii of circle. Okay. So I guess the last one is maybe a little bit more of a jump. If we bisected this shape in the middle, we know that this is 60 and this is 60. If I bisect this angle here, what's the two sides of my angle going to be equal to? 60. So what do we actually have here?
Symmetry.
an equilateral triangle.
Yep, two equilateral triangles. And one of the properties of those is all of their sides are the same length. Okay, and so we'll just say here that since our rhombus is made up of two, in this case, equilateral triangles, those other two sides are the same length as well. Okay, so since we'll call it HXKJ is made of two equilateral triangles, all sides are the same length. In fact, we probably could have done that first before we even looked at the radii of the circle. Alright? So, yeah, that particular question, you're just sort of answering it in words, but you're giving your geometrical reasons why. Okay? Alright. And is that it?
Yeah.
Great. So